figure 8, we have a triangle with given coordinates for the vertices at S and T and U. And in the description it says we're trying to do two things. First, we're going to look for point P, which is supposed to be the midpoint of ST. So it's going to be somewhere in here, but we want the exact coordinates. And then we're going to use the median that goes from vertex U to that midpoint that we find. And we're going to use that median to solve for the centroid, which should be somewhere in here. So let's do those two things. The first thing is to find the median, point P, that's out here. Well, that's simply an average of this coordinate and this coordinate. So if I write those out over here, S is at 5, 5. T is at 11, negative 3. And so in order to find point P, we're simply going to take the average of these two. 5 and 11 is 16, and divide it by 2 since I've got two coordinates here. 16 divided by 2 is 8. That'll be my x coordinate. And I do the same thing over here. 5 and negative 3 is 2. But then I divide that by 2, and so my y value must be 1. Point P must be at 8, 1. And if I look at this grid, I'm going by 2. So 2, 4, 6, 8, and up 1. That's about where we had estimated it. Point P is at 8, 1. So now I'm going to use point P, and I'm going to draw a straight line that's a median that goes from point U, the vertex, to the midpoint here. And I could use the 2/3 rule in this case to find point Q, our centroid that needs to be in the middle. Well, I go from, since a horizontal line, I really care about the distance that goes from a y value, or excuse me, an x value of negative 1 to an x value of 8. So that tells me this total distance of the median is 9. Remember, we can use the 2/3 rule that tells us from the vertex, I've got 2/3 over is where I'm going to find my centroid. If this whole distance is 9, that means each of these thirds must be 3. If each of those thirds is 3, I need to find the point that is 6 away from this, because I've gone 2 of those thirds. Okay? That would tell me that this point, I'm going to draw a little line here, that we're calling point Q, we know has a y value of 1, but it's also a distance of 6 away from negative 1. This point must be at 5, 1. Okay, so we can use the 2/3 rule. It's not too difficult to use if I've got a horizontal median or a vertical median. However, it can be awfully tricky to find if you've got vertices in weird spots that are going to give you diagonal medians. So one other thing to keep in mind that we could have done here to solve for this centroid, and we could have done that without even solving this midpoint P. We could have taken all 3 of these vertices of the triangle, S and U and T, and we could have averaged them. So if you take the x values of all of those, 5 plus 11 plus a negative 1, that's a total of 15, and divide it by the 3 different points, you would have gotten 5. And if you do the same thing for the y values, 5 plus a negative 3 plus 1 is 3, and if you divide that by 3 in order to average it, you get 1. So that's a little bit of a quicker way, and it works all the time. I would suggest using this to find the centroid, regardless of whether you can use a 2/3 rule or not.